Hi students, welcome to Lakshya Academy YouTube channel. In previous video we completed transistor as an amplifier, and today I discuss transistor as an switch. So before going to explain the transistor as a switch, I brief some of the concepts regarding the transistor as amplifier. A transistor means transfer of resistance from input to output. There are two types of transistors, NPN transistor and PNP transistor. A transistor has three terminals: emitter, base and collector. In the case of NPN transistor, the direction of conventional current is from base to emitter. In the case of PNP transistor, the direction of conventional current is from emitter to base. Action of NPN transistor already we discussed, and emitter base junction is a forward bias and base collector junction is in reverse bias condition. So when a transistor is connected to an external circuit, current is due to emitter, base and collector. In a transistor, IE equal to IB plus IC, and action of PNP transistor, when it is connected to an external circuit, the positive terminal of VEB repels the majority charge carriers in emitter and they move to the base junction, and 5% only they neutralize. The remaining about 95% move to the collector region, and those holes are attracted by the negative terminal of VCB. Okay, in PNP transistor also IE equal to IB plus IC, and IB is 2% to 3% of IE only. IC is 97% to 98% of IE. Here NPN transistor as a common base amplifier. In the last video we completed this concept. And consider NPN transistor. It is connected in common base configuration. So base is common to both input and output. Okay, and here the input signal is taken as AC, a variable. Okay, input signal, AC signal. Amplifier means which amplifies the input. Observe that it amplifies. Okay, input section is forward biased and output section is reverse bias. So this n-type semiconductor is connected to negative terminal and this is connected to positive terminal. Input section is forward bias and output section is reverse bias. N-type semiconductor is connected to positive terminal. This indicates the output section is in reverse bias condition. So we know that IE equal to IB plus IC, and a current IC is allowing in load resistance RL according to Ohm's law, the potential drop across the load resistance is nothing but current into resistance. IC into RL is the potential drop across the load resistance RL. This can be written according to Ohm's law. Okay. In some of the books, the load resistance can also be taken as RC also. And in some of the books, this can be taken as VEB also. Okay. And apply Kirchhoff's second law or Kirchhoff's voltage law, and VCB voltage across collector and base, VCB equal to ECB minus IC into RL. Okay, this is the current direction of collector current. So voltage drop across collector and base equal to ECB minus voltage drop across load resistance. Okay, so VCB equal to ECB minus ICRC. In the previous video, I consider this as VCC, no problem. Yeah, phase relation between the output and the input signal. We have the expression VCB equal to ECB minus IC into RL. Okay. During the positive half cycle, the input signal is forward bias of N-type emitter decreases. So because N-type is connected to negative, so if it is forward bias, the emitter current decreases. If emitter current decreases, from the relation IE equal to IB plus IC, if there is decrease in emitter current, there will be decrease in collector current also. Because compare with emitter current and collector current, base current is very small. Base current is in the order of microamperes only. Micro means 10 power minus 6. 1 microampere equal to 10 power minus 6 ampere. So in the positive half cycle, and there is decrease in the emitter current, so hence collector current also decreases. If collector current decreases, this factor IC into RL also decreases. Observe carefully. If IC decreases, the factor IC into RL also decreases. So voltage drop across the load resistance decreases. And if this value decreases, for example 8 equal to 10 minus 2, if this factor decreases, IC into RL decreases, VCB increases. 8 equal to 10 minus 2, 2 decreases to 1, 10 minus 1 becomes 9. So VCB increases. So by decreasing IC value, there will be decrease in voltage drop. So VCB increases. So the output signal is positive for positive input signal. VCB, voltage across base and collector, increases. So output is positive for positive input signal. Already I mentioned in the graph. Yeah, during negative half cycle and the forward bias of n-types emitter increases because emitter is connected to negative terminal. So the emitter current increases, hence collector current also increases. If collector current increases, the factor IC into RL increases. Okay, 8 equal to 10 minus 2. If this factor IC into RL increases, so 10 minus 3, 7, VCB decreases. So voltage drop across load resistance increases, so VCB decreases below the normal level. So output signal is negative for negative input signal. Observe carefully. For positive half cycle, output signal is positive for positive input and output signal is negative for negative input signal. So this indicates that input and output are in same phase. Input and output are in same phase in the case of common base configuration amplifier. Note down, in the case of common base amplifier of NPN transistor, the input and output are in same phase. Actually, this is a previous entrance exam question, 2017. What is the phase difference between input and output in the case of common base amplifier of NPN transistor? This is previous entrance exam question only. Okay, so note down that in the case of common base amplifier of NPN transistor, the input and output are in same phase and output is positive for the positive input and output is negative for negative input. Yeah, consider the PNP transistor as an common base amplifier and same as that of previous one, and consider a PNP transistor and base is earthed. Base is common to both input and output, and so we observe what happens if positive for positive cycle and a negative cycle in the case of common base amplifier of PNP transistor. So input section is forward bias and output section is reverse bias, and in this case IE equal to IB plus IC, and the voltage drop across load resistance RL is IC into RL. So this can be written according to Ohm's law, and this is the potential difference, potential drop across the load resistance RL. So by using Kirchhoff's voltage law or Kirchhoff's second law, and we can write voltage across collector and base VCB can be written as ECB minus IC into RL, same as that of a previous one. But in the previous case the current IC, and in this case current IC is different. Okay, yeah, phase relation between output and input. So the same way, and we consider the, in first case we consider the positive half cycle, and during the positive half cycle forward bias of p-type emitter increases. If it increases, emitter current increases. So if there is increase in emitter current, collector current also increases. So the factor IC into RL increases. voltage drop across load resistance increases. So it means that VCB decreases. VCB decreases. So P-type collector is negatively biased. So decrease means that collector becomes less negative with respect to base. Output increases above the normal level. VCB increases means, it follows that VCB decreases means the collector becomes less negative with respect to base. Output increases above the normal value. So output signal is positive for input signal. And during the negative half cycle, the output signal is negative for negative input signal. So in the case of common base amplifier of PNP transistor, input and output are in same phase. Next, NPN transistor as common emitter amplifier. Consider NPN transistor, and emitter is common to both input and output. According to Kirchhoff's law, Kirchhoff's second law, VCE equal to ECE minus IC into RL. This is according to Kirchhoff's second law. During the positive half cycle, there is increase in the emitter current, hence collector current increases, voltage drop across load resistance also increases. So VCE decreases below the normal level. So the output signal is negative for positive input, and during the negative half cycle, the output signal is positive for negative input signal. So output and input are out of phase by 180 degrees. In the case of a common emitter amplifier of NPN transistor, input and output are out of phase by a value of 180 degrees. Next, PNP transistor as an common emitter amplifier. And in the case of common emitter amplifier of a PNP transistor, the input and output are out of phase by 180 degrees. And the output signal is negative for positive input signal, and output signal is positive for negative input signal. Next topic, NPN transistor as a switch. Consider NPN transistor. It is connected in common emitter configuration. Emitter is common to both input and output. And we know that according to Kirchhoff's first law, IE equal to IB plus IC. Base current, emitter current and collector current. And voltage drop across RC is IC into RC. potential drop across RC is load resistance RL or RC, IC into RC, and by Kirchhoff's second law we can write VBB equal to VBE, voltage across base and emitter, plus IB into RB. And VCE equal to voltage across collector and emitter is VCC minus IC into RC. Kirchhoff's second law can be applicable for a closed loop. Okay, closed loop. VCC we are moving opposite to the current direction, so VCE equal to VCC minus IC into RC. Here VBB equal to VBE plus IB into RB, voltage drop across the input resistance. The input voltage is VBE plus IB into RB, and output voltage is VCC minus IC into RC. Here, if we consider this closed loop, we can write VI equal to VBE plus IB into RB. And if we consider this closed loop, V naught equal to VCC minus this closed loop. Okay. A graph is drawn between input and output, and in the graph I mention three regions: cutoff region, active region, and saturation region. Now we discuss how it works as an switch. How it works as a switch, a transistor as a switch. Consider the change of output voltage with input voltage from 0 to higher values. Case 1, when input is less than that of 0.6 volt. If input voltage is less than that of 0.6 volt, in the case of silicon crystal, it don't allow the current, there is no collector current. So if there is no collector current, IC into RC becomes 0. So if IC into RC equal to 0, the output is V naught equal to VCC, simple one. So if output voltage is VCC, the transistor is said to be in cutoff state. Cutoff state I mentioned in the graph. In the second case, if input is in between 0.6 volt and 1 volt, and there is some collector current, so IC into RC has some value. output V0 decreases. So in this range IC increases almost linearly, so V0 also decreases linearly, and in this region, when the input voltage is in between 0.6 volt and 1 volt, the transistor is said to be in active state. Output decreases linearly. Case 3, when input voltage is greater than that of 1 volt, so the collector current becomes maximum and output decreases towards 0 and the transistor is in saturation state. Okay, the relationship between input voltage and output voltage called transfer characteristic curve of a transistor in common emitter configuration. And in the graph, cutoff region, active region and saturation region are mentioned. So when input voltage is less than that of 0.6 volt, the transistor is in cutoff region, and when the input voltage is in between 0.6 volt and 1 volt, the transistor is in active region, and when input is greater than that of 1 volt, it is in saturation region. IC is maximum. So in cutoff state, the input voltage is very low, so transistor is not working, so it is nothing but it is in off condition, it is in off mode, and in saturation state Vi is high and the transistor is conducting, and the value of IC becomes maximum, it is in saturation region. So if the transistor is in conducting mode, it is nothing but it is the on state. So a transistor can be act as switch on or switch off. So in cutoff region it acts as a switch off state, in saturation region it acts as a switch on mode. Okay, so this is the explanation of a transistor acts as an a switch. So this is the part 3 of semiconductors, and input signal alternating current signal you learn in detail in AC circuit chapter. Okay, thank you.